uv minus the integral of v du. Now, at first glance, that probably doesn't make much sense, but it will. Let's take an example problem. Let's take the integral of 1 to the e of x times ln x. Notice these two functions, x and ln x. These functions are being multiplied together to create a product. Now, anytime you see a product of two functions where u substitution will not work, immediately start thinking integration by parts. So, the acronym we'll use is LIATE. This stands for logarithmic, inverse, algebraic, trigonometric, and exponential. This is a priority from greatest to lowest of the priority of what our u will equal in the expression. So let's look what we have. We have x. X counts as an algebraic since there's nothing else attached to it. Now look at ln x. ln x is logarithmic, so it has priority over x. That means that we'll be setting u equal to ln x. Now we need to take the derivative of u, and we get 1 over x times dx. Now we have du. Now the last variable we need to substitute this into our expression is v. Now remember, we still have this x left over here, right? We can let dv equal x. Now, in order to get v, we can take the integral of x. The integral of x. This will equal v. The integral of x using our standard antiderivative power rule will give us x squared divided by 2. Now we're ready to substitute back in to this equation here. So let's put in u. We said u is equal to ln x times v, which we just found, is x squared divided by 2 minus the integral of x squared divided by 2 times du, which is 1 over x dx. Now what I'm going to do is, to make it look a little nicer, I'm going to bring x squared in front of ln x. And now I'm going to deal with this integral. So this integral looks like we're going to do another integration by parts because we have two functions multiplied by each other. However, we actually can do this. Let's multiply these functions and see what we get. X squared over 2 times 1 over x. Notice how one of the x's can cancel. And if you want to look at it like this, you can look at it as x squared divided by x times 1/2. Looking at it like this, you can see how the x's cancel out, but you also can see that the 1/2 is constant and can be pulled out of the integrand completely. So let's rewrite this. Now, minus 1/2, because we pulled the 1/2 out of the integral because it's constant, and x squared divided by x is just x. So all we're left with in the integral is x times dx. We already found that the integral of x is x squared over 2. So let's substitute that. X squared divided by 2 times ln of x minus 1/2, and let's put in brackets x squared over 2 so you can see how this happens. Now we can bring in this negative 1, or we can just bring in the 1/2 for now. And we can rewrite this as minus x squared divided by 4. Now, if we didn't have bounds, we could just add plus c and we'd be done. But for integration by parts, if you have bounds, you must apply the bounds to the entirety of your function that's simplified. So our bounds were 1 to e. Let's start with the top bound, or the upper bound. Let's substitute e in the expression for x and start simplifying. It's e squared divided by 4. Okay. Let's start on the left-hand side. E squared divided by 2 is going to stay for now. But notice the natural log of e. The natural log of e is just 1 minus e squared over 4. Notice that the 1 doesn't really matter. And we just have e squared divided by 2 minus e squared over 4. To make this simpler, we can get common denominator. If we multiply the top by 2 and the bottom by 2, we'll have a common denominator. 2e squared divided by 4 minus e squared divided by 4. We subtract one of the e squares and we have e squared over 4. That is the upper part. Now we can evaluate the lower. So let's do that. Let's substitute 1 in as x. So 1 squared divided by 2 times the natural log of 1 minus 1 squared divided by 4. Notice that the natural log of 1 is actually just 0. So we have 1 squared, or 1 over 2, sorry, times 0 minus 1 over 4. This part of the equation cancels, and we're left with negative 1 over 4. Now, the final part of the problem is to take f of b minus f of a, or the upper minus the lower. So f of b minus f of a is our upper valuation, which is e squared over 4, right? Minus 1 over 4. Do not forget your negative. It's f of b minus f of a, and you already have a negative sign right here. So we have to, negative times a negative gives us a positive. So we now have e squared over 4 plus 1 over 4. Notice how both of these have a common denominator. They're both 4. So we can combine them to get e squared plus 1 divided by 4. That's the final answer. Let's take another integral. Let's take the integral of x times sine of 7x. How would you do this one? Well, it's the same concept as we applied above. We have two functions that are being multiplied together, giving us a product. And u substitution will not work here, because as you can see, if we let u equal 7x, the derivative of u is 7 times dx, and we still have this extra x here. So it will not work. We will have to use integration by parts. So we know that we use the acronym as seen here. We know that x falls as algebraic, and the trigonometric is sine 7x. So algebra wins, and he gets to become x, or u. So u equals x. Taking the derivative of u, we get 1 times dx, which is just du equals dx. Now we have this dv, which equals sine of 7x. We need to take the integral to find what v is. So we take the integral of sine of 7x. Now, this is where u substitution can be applied. If we let the angle u equals 7x, if we take the derivative, we get 7 times dx. If I divide both sides by 7, I get 1 over 7 du equals dx. Now I can substitute back in. We now have v equals the integral of sine of u times 1 over 7 du. We can take out the 1 over 7 and get the integral of sine u. Now we know that the integral of sine is negative cosine. So we really now have negative 1 over 7 cosine of u, which u we set as 7x. Now we can build our formula. U v minus the integral of v du. So what is u? U is equal to x. V is this. Negative 1 over 7 cosine 7x minus the integral of negative 1 over 7 cosine 7x times, what is du? Du is just dx, as we found above here. So let's simplify this. X times negative 1 over 7. How can we simplify that? Just multiply. We now have negative x over 7 times cosine of 7x. We still have this integral minus negative 1 over 7 cosine of 7x. So now let's not worry about the left side of the equation. Let's worry about what's in the integral on the right. Let's integrate this function. If we let u equal 7x, we find that the derivative of u is 7 times dx. Now notice in the integral we have negative 1 over 7. That is just a constant that can be brought out of the integral completely to make it negative 1 over 7, the integral of cosine of 7x times dx. Now, let's take this du down. We can actually get rid of the 7, or move it to the other side, by doing 1 over 7 du equals dx. Now we have dx by itself, and that's what we wanted. So we can rewrite it as negative 1 over 7, the integral of cosine of u times 1 over 7 du. Now notice again that the 1 over 7 can completely come out of the function and multiply with the negative 1 over 7 that's outside already. That would give us negative 1 over 49 of the integral cosine of u times du. Now, the integral of cosine is sine. So we now have negative 1 over 49 sine of whatever u is. What do we set u as? 7x. So it's 7x. So now let's bring down all of this function here that we didn't solve yet. We had negative x over 7 times cosine of 7x. Cosine 7x minus, I'm going to put this in brackets so we do not mess up our signs, negative 1 over 49 sine of 7x. So in order to simplify this, we keep what's on the left because there's nothing else to simplify, but we can distribute this negative in to give us a positive 1 over 49 sine 7x. Now do not forget plus c, because this integral is not defined, it doesn't have bounds, so we must add the constant of integration. This is the final answer. I hope that you guys now understand how to solve integration by parts in Calculus 2, and will do well on your exams in Calculus 2. Have a good day.